So welcome back. In this video we're going to talk about parallelograms and other four-sided shapes. I'm just going to quickly go through all of the rules for the four-sided shapes that we're going to see, the kind of rules and things you need to know about them, and then in the next video we're going to start looking at questions they're going to ask about these shapes. Alright, so first one's first is a square. So a square obviously has four equal sides. All of the angles in the corners are 90 degrees, like here. So here, they're all 90-degree angles. And the diagonals bisect each other is the other important thing. So the diagonals, so from one corner to the other, this red line here, it cuts the other diagonal in half. So that means, that's what I mean when I say the diagonals bisect each other, and they also form a 90-degree angle, and that's what I mean here. So I have this little L drawn in here. That means that this angle here is 90 degrees. So these dots here, or these lines, mean that all of those lines are the same. So that's the same length as that, the same length as that, same length as that. And the little L's in here mean that all the angles are 90 degrees. Alright, so we'll move on to the rectangle now. You guys should all know that stuff about the square. The rectangle is quite easy as well, just that opposite sides are equal. So obviously that is equal to that, and that is equal to that. And then there are 90-degree angles in the corners. Again, that should you guys should have known that. So just that each corner is 90 degrees. And the last one then is that the diagonals bisect each other. So again, this line is the same length as this line, the same length as this line, the same length as that line there, and that's shown just with this little red line through each of those kind of larger red lines. Yeah. The next one, the parallelograms, and this is kind of what the hardest stuff is. You might not have known all this stuff before. So parallelogram looks like this. The opposite sides are equal and the opposite sides are parallel. So it's basically like a rectangle that's just been pushed to the side a little bit. So yeah, this side is still going to be the same length as that side, and that side is still the same length as that side. Yeah, so it's still like a rectangle. This side is parallel to that side, and then this side is parallel to that side as well. Yeah, so obviously these two are parallel and those two are also parallel. The opposite angles are equal. That's another important thing. So this angle here is opposite to this angle, so that means they're equal. So I have that marked in there. They both have those blue angle markings. And then as well, these ones, so this angle is equal to this angle, and I have that marked in just with the dot, okay? Because they're opposite each other, they face each other in the parallelogram, that means the angles are going to be equal, okay? So I just quickly drew in there those red lines, and that's just, again, the bisectors. First, I just wanted to show you guys it without the bisectors. So now, again, the diagonals, they bisect each other. But one thing, so it's a little bit different from the rectangle. Say in the rectangle here, if you look up, all of these are the same length. However, here they're not all the same length. This half is the same length as that half. So on that one diagonal here, it cuts that diagonal in half, which means that this length here is the same as that length there. And then the same thing is true that this diagonal here is also cut in half. So it's cut in half at this point here, which means that this portion is the same length as this portion. Okay, so all these, even though they seem like kind of tiny, unimportant things, they can all be pretty important when you get a difficult question and you have to prove things, say, about these two triangles here. So it's really important to know that this length is the same as that length, this length is the same length as that length. So it might seem like a lot of info to learn, but when you start practicing it, you'll just kind of know automatically that this is the same length as that. So it's just about practicing them. Yeah, so that's just the point I made there, that dissected bits aren't equal on different diagonals, and that's just what I've been talking about, that isn't equal to that, but that this is equal to that bit there, okay? And then also, this is a really important point, that the diagonal, so a line going through the diagonal, cuts the parallelogram into two congruent triangles. So we looked at congruent triangles before this, so that means that this triangle here, I just drew in the white, is congruent to this triangle here. I'm just drawing in the blue, okay? Because it cuts the parallelogram into two triangles, and those are completely identical triangles. Yeah, so that's a really important point. And then also, so also I just drew a quick little parallelogram here. If the bisector or the diagonal is going the other way, so instead of going from why does that always happen? Instead of it going from left to up from left to right, if it's going down from left to right, like this one here on the left, then it's still two congruent triangles. So this triangle it makes, so again it cuts the parallelogram into two. One triangle there should be congruent to this triangle there. So again, I know that that's a little bit messy, the two triangles I've drawn, but the point still stands that that triangle is congruent to that triangle. Okay, it doesn't matter which way the diagonal is going. Okay, now we're into the last shape, which is going to be the rhombus. So a rhombus is just like a square that's been pushed to its side, so it's pretty similar to a parallelogram, just that all four sides are equal. So as you can see here, that this side is equal to this side, equal to this side, is equal to that side there. Again, opposite sides are parallel, so if you want to draw the arrows in, you can, just to show that they're parallel. And then the opposite angles, again, are equal, kind of like a parallelogram. And then another drawing down here, the same rhombus, just with the diagonals in. So the diagonals, one, they bisect each other, so that this is the same as this, because this is one diagonal that's been bisected. And then also that this bit of the diagonal is the same as this bit of the diagonal here, because again, this entire diagonal has been bisected. So hopefully that makes sense. The diagonals bisect the corner angles. This is quite important. So if you look up here, we had this corner angle here. So say, for example, that corner angle is 40 degrees, okay? Once you draw the diagonal in, it dissects that, or bisects it into two separate angles here. So like I have drawn here in the white, two separate angles, and each of those angles is going to be 20 degrees. These are just random numbers. That works for any number, but it's just to show you the point that it cuts it equally, all right? And then the same occurs for, let's get rid of those. The same occurs here as well. So this gets cut in half too. So the diagonals always bisect the angles. And then the last point is just that the diagonals make 90-degree angles with each other. So again, it's kind of like the square at the start, that all of these are 90 degrees. Yeah? So that's all there is for this video. In the next video, we're going to start looking at the areas of parallelograms and triangles and how we can use those areas to solve questions. And also these rules here. We're going to need to learn all of these off and use it to solve problems later on in the next few videos. So I hope you enjoyed the video. I'm going to leave it there. We'll see you in the next video. And don't forget to like and subscribe and share them with your friends if you find them helpful. So thanks for watching.